Great! Now let us see how to compare the meaning of different texts. From OpenAI, import OpenAI. Import OS. API underscore key equals os.environ, OpenAI underscore API underscore key. Client equals OpenAI, API underscore key equals API underscore key. We define a list named texts. We add our first string about OpenAI. We add a second string about machine learning. We add a third, unrelated string about bananas. Closes the list of texts. We call the OpenAI Embeddings endpoint using our client object. We specify the embedding model to use, here a small, fast model. We pass the list of texts as input to embed them all at once. Closes the embeddings creation function call. We begin with a comment stating we are using simple cosine similarity. We import math to help us do some calculations. We define a new function named cosine underscore similarity. We find the dot product of our two number lists. We find the length for the first vector. We find the length for the second vector. We divide the dot product by the product of the lengths. This gives a number between -1 and 1. We add a comment that we are computing similarities. We compare the embedding for OpenAI with machine learning. We compare the embedding for OpenAI with bananas. We print out the similarity for OpenAI versus machine learning. We print out the similarity for OpenAI versus bananas. This will help us see which texts the model thinks are related. Running the cell now. The output shows cosine similarity scores comparing the first text embedding with the second and third texts. Notice how the score between the first and second texts is 0.48, indicating a moderate relatedness, while the score with the third text is very low at 0.04, meaning they are largely unrelated. This demonstrates how embedding vectors can quantify semantic similarity between different sentences. If your scores match what you expect, our code is working.